Hello, Legacy Savers. This is the Exponential and Logarithmic Function Semester 2 review video. In this unit, we focused on exponential growth and decay, and we also graphed some logs and exponential equations as well as solving them. The first thing that we accomplished in this unit was graphing of an exponential function. The very first thing we always had to identify was the parent function. Now remember, your parent function is the guy with the base to the power. So my parent function in this case is y equals 2 to the x. Well, what I'm going to do is I'm going to write out my parent table. Remember, our x values were always the same stuff. -2, -1, 0, 1, and 2. And then what we did to generate those y's is we took those x values and we plugged it in for this x. So we said 2 to the -2nd power. And we're like, well, you know what? That's 1/4. And then we said 2 to the -1st power. We're like, well, that's 1/2. 2 to the 0, 1. 2 to the 1st, 2, and 2 squared, 4. Then we did all of the transformations. So remember this -2, this -2 times, that was not only a reflection in the x-axis, but also a vertical stretch. So we ultimately need to change the y's by that value. And we're going to multiply by it. This +3, remember that was our horizontal shift. So I'm going to subtract 3 because remember it was opposite of what we thought. And then we have to do our vertical shift. And we're going to add 3. So now we're just going to do some math here just to get some back here. I'm just going to do the math. -1/2 plus 3 is 2.5. -2 times -1 is 2. -2, 1, -4, -1, -8, -5. All right, so I'm going to graph those dots here. 1, 2, 3, 4, 5. 1, 2, and a little bit more. There's one dot. 1, 2, 3, 4, and 1, 2. -3 and 1. -2, -1, and -1, -5. 1, 2, 3, 4, 5. All right, and then what I'm going to do is I'm going to connect those dots. Kind of makes a curve, kind of like that. There were arrowheads on both sides, but do remember that this one had an asymptote, and its asymptote was always where that vertical shift was, because normally it's at 0, but if I vertically shift up or down, we also have that happening. So right here is where that asymptote is on this equation. So my asymptote would be y equals 3 in my case. And then my domain, I have to find, it goes forever in the negative direction, so negative infinity. It looks like it goes forever positive, so we're going to say negative infinity to infinity. My range looks like it goes all the way down, so we're going to say negative infinity, but it stops at 3, so we do have to note that we're stopping at 3 there. The next part that we did is we wrote exponential functions given some information. So these ones, f of 2 is 45 and f of 4 is 405. Well, we were probably like, well, Marsh. Remember, these guys had to look something like this. They were a times b to the x, and a was our initial value. That's how much we started at the 0 spot. And then this b value was your multiplier. What are you multiplying by each time? So first thing I like to do is make a table. So I'm going to make myself a table. And I'm going to make sure I start with 0 each time. Otherwise, I do get lost. 2 is 45. 4 is 405. Now, what I need to do is I need to figure out my multiplier. But the multiplier has to be a perfect multiplier, like, so basically you're going but by ones on the x value. Well, it looks like I'm going up by a number twice, the same number twice, but all together from 45 to 405, if I divide those, I get a value that I multiplied by 9. So ultimately what I'm thinking in my head is some number times itself twice gave me 9, which is 3, right? So I can now work backwards to get to the 0 spot. So 45 divided by 3 that's 15. 15 divided by 3 is 5. So my initial value is 5, and my multiplier is 3. So my equation will be 5 times 3 to the x for my final answer there. This one, once more, well, it looks like we're going to need to make a table. It looks like I have an initial of 0, 1, 2, 3, 4. And then, oh, skipped 1, but I do have 2, 1. Oh, how did this happen? Well, multiplied by a number twice, and it looks like between the two, it looks like I multiplied by a fourth. So what number did I multiply twice? And now I'll get a fourth. Well, if I think about it, right? Guys would agree with me. There's probably a 2 here because 4 divided by 2 and divided by 2. That would make sense, right? So technically I'm multiplying by a half each time because dividing by 2 is the same as multiplying by a half. So I have my multiplier, have my starter value. I'm going to write that out. 4 times 1/2 to the x power. The next portion was us using our calculators and also just converting between our forms. So we had to convert from exponential form. And remember, we always started on the base of the log, went to the 3, and then made it 64. Remember, it made an E. So we're going to say 4 to the third is 64. That's what we're always going to do, start in the base. Now, if I'm in exponential and I need to go to logarithmic, we always started still with the base, but we did have to put a big giant log in the problem. And this one kind of made like a G. So we started at the 16, go to the 1/4, and then go to the -1/2. So I'm going to say log base 16 of 1/4, and that's going to be equal to -1/2 for an answer. Very quick, very easy problems. Number 6, we had to evaluate using our calculator. Remember, those of you that are using your graphing calculator, you're going to be pushing the alpha button, and then you're going to push the window button, and you're going to go down to number 5. Those of you that are using your scientific calculator, you're going to want to do log of 7 divided by log of 4. So log of inside divided by log of little base. For this one in particular, you will get an answer of, Marcia's going to go grab her calculator out here. She doesn't have it out. I get an answer of 1.4037. Okay, so depending on how you do it, doesn't matter how, just make sure you know how to get that value. And then we worked on expanding and condensing. Now remember, when we saw multiplication, that made us go to addition. So we changed that to addition. When I saw division, I changed that to subtraction. And then the other thing that happened is if I saw a power, I made that a coefficient, a number in the front, right? So ultimately, what we're going to do, I see multiplication, so I'm going to change that to addition. And every time I add, I'm going to add a brand new log. So I'm going to say log base 8 of 3 plus log base 8 of x squared plus log base 8 of y cubed. All right, so close, so far. But we now have powers, so I'm going to make those coefficients. So I'm going to take this number, I'm going to go drop them in the front. I'm going to do the same thing to the 3, drop them in the front. Notice, log base 8 of 3, he doesn't have nothing, so he's just going to stay over there, just kind of hang out. He's not going to get a coefficient because there's no exponent on that 3. But now I'm going to get 2 log base 8 of x and 3 log base 8 of y. And that is done. We have expanded. There is only one thing inside of each logarithm, and that means we have expanded it fully. Condense now, we have to condense slowly. And with condensing, I kind of go backwards, I guess. So I'm going to look for coefficients. I'm going to make those powers. So these 2 and this 3 are going to go become powers again. So we get log base 4 of x squared minus log base 4 of n cubed. And now I see subtraction, so that's going to become division. And ultimately, we are going to only have a single log in any condensed problem. We should never have more than one. So I'm going to say log base 4 of x squared divided by n cubed. And that is fully done there as well. And then we did a bunch of solving. So remember, when you are solving, first ones we have are exponentials. When you are solving an exponential equation, you want to get the base alone. So I have, is that e to the 0.2x? It is, I think. Marcia's got to make sure she pays attention to that. So 0.2x, I'm going to get that 6 over to the other side. I'm going to put a 5. And then remember, we're stuck in exponential, so we got to go to log. Ultimately, since it's an e, we are ultimately going to get a log base e, or ln. So we're going to have a natural log of 5 equals 0.2 to the x, or times x. ln of 5, I'm using my calculator here. I get a value of 1.6094, and I'm going to set that equal to 0.2x. Divide that by 0.2, and we are going to get an answer of 8.047 and 2. There we go. Next one, same thing, just a different base, right? So we still need to get this 7 to the 2x. This needs to get alone right here. So we're going to add 9 over and get 19. And now I'm stuck in exponential. Can't do anything with this 2. So I'm going to go to log. So I'm going to say log with a base of 7 of 19 is equal to 2x. Now, log base 7 of 19, I need Mr. Calculator. So I'm going to go to Mr. Calculator. I'm going to type that in. I'm going to get an answer of 1.5131 is equal to 2x. Dividing by 2, we are going to get an answer of 0.7566, it looks like, for an answer there. And the last two, we are now in logarithmic form. We need to ultimately probably go to exponential at the end. First thing, I need log and everything alone, inside of it, alone. So I'm going to add that 3 over. I'm going to divide by 7. Yes, is that disgusting? Yes, but it's all right. Log base 5 of x is 18/7. And now I'm stuck in log. Can't do anything because the log's alone. So I'm going to go to exponential form. So 5 to the 18/7 is x. I'm going to type that into my calculator. And we get an answer of 62.7121. Now be careful. Logarithms, they do have extraneous solutions. How do we have them, you ask? You're like, oh, Marsh, I forgot. Remember, logs cannot be negative or 0. Okay, so if I substitute this in and that becomes a negative or becomes 0, it's not a good answer, and you're going to have to mark it as such. In this case, there's no problems there. The number is awesome. Let's try the last problem. So I'm going to add 4. I get negative 2 ln of 2x is equal to negative 10. Divide by negative 2, because I'm just getting that natural log alone. Now, stuck in natural log, let's go to exponential. And you're probably like, Marsh, what's the base on an ln? Well, it's definitely an e. Remember, natural log and e are connected. So I'm going to convert. I'm going to get e to the 5th is equal to 2x. E to the 5th, again, Marsh is going through her calculator here. Oop. And I'm getting e to the 5th is, I'm going to move up here, 148.4132. That's equal to 2x yet. I'm going to divide by 2. And we are going to get an answer for x of 74.2066. And that is the end of the exponential and logarithms semester 2 final review. I hope to see you later, Sabers.